I'm Adam Tank. I'm the co-founder and chief customer officer at Transcend Software. I started my career as a microbiologist in a Fortune 500 food manufacturing company and quickly came to realize that that industry and role was not for me. And through a series of very fortunate events, I ended up going to business school. And during my time there, was introduced to General Electric's water division, which is no longer there as a part of GE. It's since been acquired multiple times over the years. But I was very lucky to do investments in early stage water tech companies and quickly came to find out that I loved the water, wastewater, and generally the infrastructure industry as a whole in the built world. So over a number of years, I transitioned into startups myself. So took off the investor hat and went into the operational role. I had a robotics business that was focused on the repair and inspection of water pipelines. That was acquired. And then in 2019, I got a call from my co-founder, Ari, who was interested in having me start Transcend, which is a generative design startup for the built world, specifically critical infrastructure. So we've been at it now for almost 5 years, which is hard to believe, and have been having a ton of fun with it.
So what were your goals when you co-founded Transcend? And do you feel that you're achieving those goals?
I believe, and we believe, that the way that we plan, design, and construct infrastructure, critical infrastructure, is a fundamentally broken process. We focus too much on being reactive to what's already been built. And we are oftentimes building the same stuff we have for the last 10, 20, 30, 40, 50 years with expectations that it's going to last us the next 10, 20, 30, 40, 50 years. So the reason that we founded Transcend and our goals are to help the people responsible for assessing and designing and building this infrastructure. So these are utilities, these are engineers, these are equipment suppliers in some cases. Our goal is to help them look at outcomes as early on in the process as possible and spend their time designing infrastructure that is going to be resilient and sustainable for future generations. You ask how we're doing on that, if we're achieving that goal. My answer would be yes, with a caveat that we have a hell of a lot of work to do. So to date, the software has been used in over 70 countries, and users have designed over 20,000 projects in the tool. We started in wastewater. We have since moved into drinking water and industrial wastewater. And just last year, we entered the power industry. So we have definitely made our impact, over 170 million people impacted to date. But of course, there are billions more that still need access to clean water, clean power, reliable sources of transportation, et cetera. So a lot more work ahead of us.
You said that people should be looking at outlooks and outcomes before they start building. Can you give a couple of examples of those?
I would love to. So if you think about when we build infrastructure, what exactly we're trying to accomplish, and let's use a wastewater treatment plant as an example. Take a city in the U.S. Let's say, name a large city. Let's say city of Los Angeles as an example. Have a couple million people living in the city itself, and we anticipate that the population of the city of Los Angeles will likely grow in the future. That could be in the span of 5 years, 10 years, 15 years. But we know it's going to grow, but we don't know by how much. Are we going to have 500,000 people living in the area? Are we going to have 1 million? Are we going to have more industry built there in the future so that not only does the population grow, but the amount of water and wastewater used grows exponentially with it? We can't accurately predict the future when it comes to what is going to be expected of the infrastructure that we're building today, what we'll need it to do in the future. So to the extent that we can evaluate all of those potential scenarios before we design and construct this infrastructure, we can effectively de-risk the likelihood that we build something that doesn't function for us in a couple of decades. And in my opinion, the only way to do that is to bring technology into the forefront, because the way that we traditionally manually design and manually assess these projects, we do not have the time or capacity to do it effectively if we want to assess all of these potential outcomes and future scenarios.
So you recently spoke at Autodesk University 2023. Can you summarize your presentation there?
It was a fun session. It's the second time I've got a chance to speak at Autodesk, and it was part introducing the concept of generative design to the to the folks that were in the audience, just over 100 this year, which was fantastic, pretty exciting. And part of it was the real world applications of generative design in projects. And we focused specifically on water, wastewater, and power projects. So what we discussed was the use of generative design tool, ours, Transcends, in helping a water utility in the US go from evaluating 3 of those potential future scenarios for what they wanted to build as far as their wastewater treatment plant was concerned, to then evaluating 30 different scenarios in the same time and budget that they had allocated before. And so we walk through not only the procurement process around how they procured software like ours, but then also where the software was used as part of this project, and then what the outcomes were that were achieved. So at the end of it, participants had a pretty good understanding of what generative design means, specifically in the AEC world, but then also how it's applied in some real world implications of technology like the Transcend Design Generator.
So I noticed in a lot of places, including at the conference, where the phrase generative design has seemingly been replaced by just AI since that's popular. Do you consider those two terms interchangeable, or do you think that there is a distinction?
There is a distinction. They are not interchangeable. If I could show you a graph, I would. If I'm here waving my hands for those that may not be able to see me right now, they work. They can work well with one another, but they are wholly independent disciplines and methodologies that can be used to tackle different types of projects, and not just infrastructure design, by the way, but all kinds of different scenarios. Generative design is really explains the process change behind how engineers can use technology to assess more options than they could previously. AI may be a component of how generative design functions, but in and of itself is more a mention of technology rather than a process change. So that's how I would, at a high level, describe the differences between the two.
I'm not sure everyone is making such distinctions, so I appreciate that. How can technology such as BIM and AI improve infrastructure and generative design? And the same for lessening climate change and making communities more climate resilient.
This is a fantastic question, and when I talk to people who are outside of the infrastructure industries, it blows their mind that we will spend $50 million or $100 million building an asset that we can't visualize before it's constructed. We spend huge sums of money on things like a water or wastewater treatment plant, and we only know what they look like when we can actually walk through the front door of the facility. And that's a really big problem. So let me give you an example why. I mentioned that an important thing to think about when we're designing infrastructure is the fact that when we build it, we oftentimes have to turn around and instantly start maintaining it because it's either breaking or conditions have changed since we originally designed the facility in the first place, or we didn't assess all of the outcomes that we wanted that plant to achieve early on in the design process. I was speaking to an engineer 3 weeks ago, and he said the first 10 years of his career were spent in front of a computer designing wastewater treatment plant. And it was not using 3D modeling or BIM, building information modeling. And so this plant was constructed, and he got out of his office and went to this facility and walked in through the door. And the first thing he noticed was that he had designed a pump that was 10 feet in the air. So all of the operators and the maintenance teams responsible for maintaining that pump and ensuring that it was of sufficient operating condition couldn't even access it without getting on a ladder or having to climb over pipes or a whole bunch of other situations. And so we put the people who are responsible for operating and maintaining these systems, we put these people in a really bad position when we aren't using tools like BIM to look at what if a full facility is going to look like when it's finally built. We have technology that can build 3D models for us, or that we can use to build 3D models, but we choose not to. So that's the first challenge. As far as how it makes buildings more sustainable or resilient, another simple example of this. So there are many places in the US now that are being impacted by wet weather events that hadn't previously occurred. And when you have something that was built 20 or 30 years ago, and we could use, I mean, let's use a bridge as an example. You have a bridge that was built 20, 30 years ago, that was built for a certain level of water going through a river. And now you have wet weather events that you couldn't have predicted 20 or 30 years ago that now get so high that they wash over the bridge and potentially at risk of knocking it out. If you can effectively evaluate what a range of potential wet weather scenarios looks like when you're designing your next bridge, you can design it to be more robust, or maybe put it in a different place, or maybe use a different type of material selection. If you're not though evaluating those scenarios or looking at what it means to have a resilient bridge or a bridge that can withstand climate change, then you're going to keep building the same bridge that you have for the last 50 years, and it's going to get washed out, and you're going to have to rebuild it again, and it's going to be a whole nightmare, which is exactly what's happening today. So by using tools like BIM, building and information modeling, having more data around what the facility or the site or the asset looks like before it's constructed, and then being able to evaluate a range of future scenarios, you can build infrastructure that's more future-proof, that just makes sense for the realities of what are going to happen in a future that we currently can't predict today.
Okay, so continuing with that bridge example, can you describe some of the challenges and differences between trying to, say, retrofit a bridge or a bridge model as opposed to designing a new bridge from scratch nowadays?
Anytime you have an existing asset, you are dealing with something that was designed to perform a particular job when the asset was constructed. So a bridge, as an example, you may have a bridge that was built 50 years ago. It was designed to handle, a certain amount of traffic, a certain amount of weight, certain lane sizes or size of vehicles, certain types of vehicles. And so when you have an existing asset and you want to retrofit it or upgrade it to make it more, to make it be able to handle the realities of today, oftentimes it's so much more difficult to do that than building it from scratch, because you have to, let's say it's a wooden bridge as an example, and you want to make sure that it stays a wooden bridge because of the aesthetics, or it's too expensive to replace with metal, or you can't knock out the whole thing to repair it or replace it with metal because it's a single source of traffic in and out of a given city or what have you. It's very difficult to retrofit a bridge that was meant to handle, your average car being, maybe a small sedan or a small coupe, if you will, to now multi-thousand-pound electric vehicles that have big batteries that are running over this bridge, or maybe semis that are now running over this bridge because there's industry that's moved in that wasn't there 50 years ago. So if you're going to design a new bridge now, taking into consideration things like EVs or new safety requirements or new materials or different sizes of vehicles, etc., by being able to model those bridges and being able to think about what are all the implications of what changes have occurred and might occur in the future, you just end up building a better bridge, or you end up building a better asset. You build a more resilient and a more functional asset that reflects the realities of today and not what it was originally designed for 50 years ago.
How much is a challenge to let's say you can't build a new bridge, but you still want to model in a modern way an existing bridge? Is that possible, and how difficult is that?
I can't speak to bridges because we're not there yet. One day we will be, I hope. It is our goal that transportation, telecommunication, all critical infrastructure is automated using Transcend software. So let's take a wastewater treatment plant as an example. There's no question it's a bit more difficult to model an existing asset because you have to tell the software what already exists and how it's performing today. Whereas if you have no infrastructure, you're just building something from scratch, you don't have to go back and sort of do that retroactive modeling. So in our case, and I would imagine to be the same for a bridge, if you wanted to model an existing asset to understand what its design capabilities are, especially since a lot of that information is lost over the years as these blueprints and plans and quite frankly, people are long gone, then you have to tell the software, what is the material of construction? What load can it handle? What is the current status of the particular materials or the particular assets? So like, do we think that this bridge has 10 years left of useful life? Do we think it has 20 years left? In a wastewater treatment plant, it could be, how thick are the concrete walls? Is there pitting? What kind of shape are they in? Is the equipment rusting? When was the last time it was replaced or maintained and repaired? Once you have this type of data, you can feed it into a model that will then tell you how this asset should operate given the existing conditions. Then you can say, now what I want you to do is given this future range of scenarios, how I want you to be able to operate in the future. And then the computer can tell you, here's the difference between what it's capable of handling today and what it's capable of doing in the future. And if there's a gap there, then that's where the work comes in effectively to either build a new one or rehabilitate the old one, etc.
So suppose you're talking to an engineer, a group of engineers who've been doing this for a while, and they remember being skeptical of BIM when it came out, but now they're on board and they've seen that usefulness. How do you explain to them that things like AI and generative design are not just hype and buzzwords, and that there's something that they need to seriously look at and incorporate into their work?
I would tell them to look at similar changes that have happened in the past. And this one has come up recently in a lot of discussions with engineering consultants, and that is the tools that we now use for estimation of projects. In many cases, either already incorporate AI or certainly sophisticated algorithms when it comes to things like material takeoffs and quantities, et cetera, or they have been built in-house as their own in-house tools, either in software or sophisticated software, meaning like automated software, or in sophisticated Excel spreadsheets that might sit within the procurement team or the estimating team or whoever that may be. I would just say look at other places where it has already been applied or you're already using it and understand that it is just as applicable today. Yes, the application may be a bit newer or something you may not be as familiar with, but in reality, from the engineers that we have spoke to, the ones that embrace these tools have a lot more fun in their day-to-day because it gives them the time to assess more innovative options that in many cases they've wanted to look at in the past but haven't had the time or the budget to do. Or they sort of look at it as a sidekick that can validate or invalidate some of the assumptions that they have and ideas that they have around a particular project and allow them to spend their time focused on the detailed work or the work that's actually going to move the needle for the client instead of the baseline sort of repetitive stuff that, right, they've been doing for however long they typically don't enjoy doing.
All right, great. Do you have any recommendations on how you can kind of speed the learning curve or kind of, I guess, take the edge off of making those initial kind of commitments?
I would imagine if any engineers are listening to this, they're probably going to laugh at me. But I would say just jump in, feet first. Um, a lot of times when we introduce new technologies, it's a little bit scary. It's not quite clear how the thing works or maybe necessarily where it fits into your workflow. You might get into a user interface and realize that it's a bit cumbersome, or maybe certain buttons are not in places that you would expect. But ultimately, if you do it and sort of struggle through those first couple iterations, I think you'll find that these tools, in many cases, are much easier to use than some of the ones you probably already are using. So if you were to take a look at, the 50th version of an Excel spreadsheet that in many cases floats around these engineering firms, that has been sort of Frankensteined over time. Any new engineer coming into the organization, it's going to take them weeks, months, potentially years to wrap their mind around how the spreadsheet works. And this is something that's been internal to the company for years. But with a new software tool, if you jump right in, just as a new engineer would, you're probably looking at days or maybe weeks worth of learning. So we oftentimes forget just how difficult it is to utilize our existing tool sets and sort of turn a blind eye to the new ones by saying, oh, well, that's too complex or maybe too difficult to use. But in reality, these tools are not any more complex or any more sophisticated than the ones that you're already using. They may just look a little bit different. So I would say jump in, be willing to learn. And at the end of the day, you can probably get some sort of continuing education credits to get your PE license or whatever else it might be to keep your career on track. So even if you end up hating the process, you can still use it for that.
So a major concern that I've been hearing a lot of, especially across the use of AI lately, is intellectual property rights. Now, users' data are incorporated into AI models in their training. So what's kind of your philosophy on this area? And do you think this is a major problem? And how do you think it's going to shake out?
I would say if you are someone who is working with or planning to work with a third-party software company like a Transcend, this should be top of mind in the questions that you're asking that business before you work with them. How will my data be used? Will it be sold? Will it be aggregated? Will it be used to train your models to make your software better or more sophisticated? These are really important questions to ask because, yes, in many cases, the data is used by people outside of the company you might be working with, or it's used to reinforce a model that they're then selling to your competitors, et cetera. That's not the case of Transcend. We don't anonymize data. We don't aggregate data. We don't sell data. all of the data that our customers input into the platform and the rules that they configure for their design practices, we consider to be their IP. So if you are someone who is seriously considering contracting with a company like a Transcend or another who's outside of your business, or for that matter, using a large language model internally that's developed by a third party, very strongly look at the terms of the contract, the terms of service, et cetera, and ensure that your data is being protected.
That's a great answer to a question I've been hearing a lot, and people aren't exactly sure what they're concerned, but not necessarily sure about what to do. Unless you've got any other advice on that, those are kind of all the prepared questions I've got. Is there anything that you felt like we should add that we may have missed?
The only thing I'll say is that it's your question earlier, Todd, around how to sort of take the edge off as you're adopting these projects. Asset owners, especially municipal utilities, engineering consultants, they're ultimately the ones who are evaluating the risk of certain projects. And in many cases, that is their job, is to fundamentally assess and reduce the risk of developing a project to fruition. And a lot of them see technology, and it's not just Transcend, but this is really any new innovative technology. They see it as adding risk into the process. And I would encourage people who are responsible for designing and building this infrastructure to think a bit differently about that, in the sense that, a tool like generative design, in my opinion, can reduce risk far more substantially than the way that we think about risk management or risk mitigation today using manual risk management practices or models. And the reason is that software is so capable of solving quite complex problems that humans are also capable of solving. The computers, though, can just solve them considerably faster, but also thousands and thousands and thousands of times over and over and over again, where it would take a human, weeks, months, years, decades to do the same level of work. So if you're thinking about innovation as being risky, I would encourage you to put on a different lens and think about how new technology can actually reduce the risk of building something that you're going to, quite frankly, regret building 10 or 20 years in the future, because technologies like these can significantly reduce the risk of building the wrong thing